Welcome to our today's online class, and I'm so much pleased to introduce to you a question here that has been extracted from a topic called matrix and transformation. So the question reads, triangle A prime, B prime, C prime is the image of triangle ABC under a transformation matrix T whose elements are given as 1, 3, 2, 2. So this is a 2 by 2 matrix. And the question proceeds and says, if the area of triangle A prime, B prime, and C prime is 25.6 centimeters squared, find the area of the object. Find the area of the object. Find the area of the object. So we are going first to come up with two different diagrams, and this can be my first diagram, okay, and I can label this diagram as A, B, C. So of course, in a layman's language, tri will mean 3, and that means this is a diagram or a figure in mathematics that has 3 edges or 3 lines, that means tri, or it has 3 vertices. So the first vertex, the second vertex, the third vertex. So it has 3 vertices. And of course, it has 3 angles. That is why it is also referred to as a triangle. This is the first angle, this is the second angle, and this is the third angle. And of course, we are told that these 3 angles, when their summation is obtained, they must be able to give us 180 degrees as the answer for that. So we have been told that this triangle has undergone a particular transformation. So the triangle has undergone a particular transformation. And we are told that the matrix of transformation is given as a 2 by 2 matrix, which is 1, 3, 2, 2. So 1, 3, 1, 3, 2, 2. Okay, so this triangle has undergone a transformation, and that transformation can either be a rotation, a reflection, an enlargement, a shear, a stretch, you see, and of course, any other transformation that gets captured or discussed in mathematics. So we are what we call a reflection, a rotation, an enlargement, you see, a shear, a stretch, a translation, you see, and the matrix of transformation labeled T is given as 1, 3, 2, 2. These are called elements. And this is a 2 by 2 matrix. Why? It has 2 rows, okay, and 2 columns. So it becomes a 2 by 2 matrix. So the order that a matrix can capture is normally identified by the rows and the columns. So the rows and the columns. And we have 2 rows and 2 columns. So a 2 by 2 matrix. The first row, the second row. The first column, the second column. So 2 rows and 2 columns. Now, that matrix has undergone that transformation by this matrix of transformation. You see? So the transformation that the matrix has to actually get associated with is called a matrix of transformation. And it gives us this triangle. I just make a sketch because it can be a rotation, a reflection, an enlargement, depending on whether the transformation is congruent or non-congruent. So, is it? And it actually ends up giving us a prime, okay, B prime, and C prime. So they have told us that the area of the image is 25.6. So they're asking us to get the area of the object. What are you supposed to do? We know very well that area of the image divided by area of the object. The answer must be equal to the determinant of the matrix of transformation. Determinant of matrix of transformation. Determinant of the matrix of transformation. So the area of the image of which the one you have actually formed after that transformation over the area of the object initially given and undergoing that transformation should be equal to the determinant of the matrix of transformation. Our end of image is given as, so let me just proceed to this end. The area of the image is given as 25.6 over, I think that is correct, okay. The area of the object unknown, so area of object not known. And this must be solved just a minute. We have 25.6 over area of object, This must be equal to the determinant of matrix of transformation. We have been given the matrix as 1, 3, then 2, 2. How do I get the determinant of this matrix? I say the product of the elements in the main diagonal less the product of the elements in the secondary diagonal. So the product, that means multiplication, of the elements in the main diagonal less the product of the elements in the secondary diagonal. So that now you end up having 1 times 2, this is the product of the elements in the main diagonal, less the product of the elements in the secondary diagonal. So 2 times 3. So that translates into, let's proceed to this end. So we shall have 25.6 over the area of that object should be equal to -4. So we shall say from this end, you can say, so we shall say times n times n. So this and this will disappear. So 25.6 should be equal to -4n squared. And that is -4n. So divided by -4, divided by -4. This and this will disappear. So we have to see what is the area of that object. 4 into 25, we shall have negative. So 4 into 25, that is going to be 6, 24. 24, that is less 1, will be 0.5. Okay, so the area of the object should be equal to 6.4 units. What are the units? Centimeters square. So we're going to have 6.4 centimeters square. That becomes the final answer for that question.